Good morning. This is your stats sensei, Mr. Spensei, and this is a chi-square test of independence assignment, handling affairs. So a random sample of 200, that's important. We have two things that are really important there. We have random sample. We also have a sample size of 200. Was selected from a large college of 35,000. That's important. That sounds like that's my population. Each student was asked to give his or her opinion about the following statement. The most important quality of a person who aspires to be president of the United States is a knowledge of foreign affairs. I think Bill Clinton thought it was domestic affairs. The responses are recorded in the table below. So we have response category. So that's one variable. Excuse me, that's one variable. And we have 1, 2, 3, 4, 5 levels. And we also have male and female. That's our second level, which is gender. In this case, we have 2 levels. Is there sufficient evidence to indicate the response is dependent on a gender? So key phrases. If it's going to be a test of independence, it's going to have one of the following words: dependent, independent, associated, or related. Dependent, independent, associated, or related. Those will be the words that let us know that it's a test of independence. Also, we generally have a table. If we have a table, it's going to be a chi-square test of independence. So, provide statistical evidence to support your conclusion. So, is there sufficient evidence to indicate that the response is dependent on gender? To indicate the response is dependent on gender, provide statistical evidence to support your conclusion. Now, one thing they don't give us is our alpha level, but I'm going to just tell you that I'm going to use an alpha level of 0.05 since they did not give it to us. All right. So first off, response category, that's one variable, and gender, that's my second variable, are independent. All right. Now, this is something that's really important. This is always like to write the hoe as a positive statement. So that my positive statement is that they are independent. But you need to make a little note to yourself. That means they're not associated. So I want you to write it as they are independent. And matter of fact, every time we do one of a test of independence, the first thing is they are independent. Something and something are independent, which means they are not associated. Well, that's a flip. Got to be careful with that. The ha, we always write it as a negative statement, which is that they are not independent. So are independent and not independent. This will be for every time we do one of these. But in parentheses off to the side, I want you to say that they are associated. So this is going to be a required, and this is going to be required. And you will always set it up like that. All right, they told us we had a random sample of 200 that was given. That was nice of us. Because now, if it had been random assignment, we wouldn't have to do the n is less than 10%, but it's not. So 200 times 10 is 2,000, and our population size was 35,000. So we're less than 10%. We're good to do random sampling without replacement. We need all expected values greater than 5. We'll have to come back to this one. So I'm going to put a question mark and say, hey, you know what? We don't know now. Let's go ahead and do our formula. So our formula is going to be chi-squared equals observed minus expected squared over expected. The next thing it's going to ask for is our degrees of freedom. Well, our degrees of freedom for chi-square test of independence is a bit different. It's going to be rows minus 1 times columns minus 1. Rows minus 1 times columns minus 1. Well, how many rows did we have? Well, 1, 2 rows. So this is 2 minus 1. And columns, 1, 2, 3, 4, 5. If there'd been a total, you don't count the totals. So don't count the total, just count the ones associated with the variable. So this is going to be 5 minus 1. Well, that's 1 times 4, which is just 4. So our degrees of freedom in this case are 4. Okay. We need to get to those expected values, and this is where we're going to go to the calculator and figure this out. Now, this is going to be a bit different. I mean, it really is. So here we go. You're going to go stat. Excuse me, you're not going to go to stat. You're going to go to matrices now, and you're going to have to enter the matrix, which is kind of cool. We're going to be like Neo. So second matrix, and you're going to arrow over. Oh, you know what? I'm going to back up and show people where I got that button from. So second, that button, the second button, and then X to the -1. Press that, and that enters the matrix. We're going to arrow over to the word edit. All right. I need it to be a 2 by 5. Why? When we were doing our degrees of freedom, we found out that we had 2 levels here, and here we had 5 levels. So 2 levels and 5 levels. So it's a 2 by 5. So 2, enter, 5, enter. And then we're just going to enter the values. So 10, enter, 15, enter, and you just keep going across till you have them entered. Once you have them all entered, it's going to be very important that you do it just like this. You're going to press second and then the button next to it, and you leave. You're like, well, I haven't done anything yet. I know. Now we're going to go stat, arrow over to test, and you can go ahead and run the chi-squared test. Now, this is not the goodness of fit. This is test of independence. So we go to just plain old chi-squared, which is letter C, and press enter. And it's going to ask for observed and expected. Well, you haven't put your expected in, but you're going to have to trust me on this. You press calculate, and we get 8.9225. And let's go ahead and write that down. Our chi-squared value is 8.9225. Our p-value is 0.063. And our alpha we said was 0.0500. This is less than, excuse me, this is a greater than symbol. So we're going to fail to reject. All right, we're going to fail to reject. You're like, well, you still haven't gone back and done your expected values. I know, but we had all that information, so let's do that. All right, now we're going to go back, and we're going to go back into the matrix. So second matrix, go over to the word edit. And this time, you'll notice that matrix B showed up, and you'll drop down to say matrix B, which you didn't do, and press enter. And now we have our values. Now remember, all of those values have to be greater than 5, and they can be decimals. So go ahead and leave them as decimals. So our first one, 13.5, 16.5. And go ahead and record all of those. So then I have an 18, I have a 22, I have another 18, I have another 22, I have a 22.5, I have a 27.5, I have an 18, and I have a 22. So I pulled all those values out of matrix B. I'm going to do that again just in case you didn't get there. So I'm going to go second, and then the X to the -1. I'm going to go over to edit, and I'm going to drop down to matrix B. All right. Now, I could go second quit, and if I wanted to see my original matrix, second matrix, edit, it's an A, and I just press enter. All right. So there it is. That's our matrix. That's our expected value. So we have all of our expected values listed. And if I look at them, all of them are greater than 5. So see table below is good. So now we need to do our plug. Well, I've always said we're going to use keep it simple, we're going to use the first one and the last one. So those are the two we're going to use. So when I'm plugging in, it's going to be chi-squared equals, well, we observed 10. We expected 13.5. We're going to square it, and we're going to put it over 13.5. We're going to leave out all the middle stuff, so we're going to put plus, dot, 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 plus. And then we're going to go to the last one. We observed 15. We expected 22. We're going to square that, and we're going to put that over 22. And that gives us our chi-squared value. And we made our decision. Our p-value of 0.0630 is greater than 0.05. And I'm going to redo that just so that you can see it again. Second quit, stat, test, letter C, A and B. The calculator automatically gives that to you. And there it is. All right, so it automatically gave me those values that I plugged in. We're good to go. So finally, camera adjustment. Our p-value is 0.063. That's what we said. So our decision was we failed to reject because it was greater than 0.05. There's not sufficient evidence at alpha equal 0.05 to suggest that response category and gender are not independent. Remember, we always restate our alternative every time. So there's our alternative, which was response category and gender are not independent. So we just restated that exactly word for word. Now, because that's a little bit weird on the English, you could have said this. Our p-value is about 0.063 or is 0.063. We failed to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that response category and gender are associated. Where did that come from? Oh, remember we put that in parentheses. So if you don't like saying it are not independent, you can say that they are associated, which is why it's super important that you do it exactly like this. All right. And for those of you who are taking an AP exam, it's going to be really important that you are able to use both words independent or are not independent and are associated. All right. I appreciate you watching. I hope this helped, and I hope to see you on the next one. Thank you.